Hello again, our most valued student. My name is Confident and welcome to this Mathematics N3 April 2018 exam question and its answers. In this particular session, we're going to look at the question paper that was written on the April 2018 and provide some suggested solutions to that particular question. Now, should you require more of these or more videos related to mathematics in N3, as we've got a full version of the whole curriculum for mathematics in N3, you can visit our website as shown in the screen, or you can email us, and our email address is info@agrilentech.co.za, or you can call us on 011-040-7343 and we will gladly help you. Now please note that in this particular memo, errors may be present. However, should there be any errors that you are going to note, these are not the responsibility of the Department of Higher Education and Training. However, these are the responsibility, or the errors were made by the person who made this memo, and in this case it is me. Should there be any errors that you picked up, please feel free to request some additions and we will make the necessary changes in the memo. And also please note that to avoid any copyright issues, no part of this video may be reproduced in any form outside the knowledge of Agrilentech College. Now, if you are requesting more of these videos, as I mentioned earlier, feel free to send us an email, or you can call us on the number that I previously provided, and we will sell them to you at a fraction of a cost. Now let us look at this particular question paper, which was written on the 26th of March in 2018, and by X they mean it was written in the morning, and Mathematics N3 is a 3-hour paper. As I said again, this is an exam from the Department of Higher Education and Training, so let us start with the first question that was asked in this particular question. It says factorize as far as possible. Now, the first keyword there is factorize, and then the next thing is as far as possible in prime factors, which means if you don't fully factorize, they will penalize you. So now let's start by the first question 1.1. They gave you 5x to the power of 4 minus 5y to the power of 8. The first thing that is easily noticeable is that 5 is common in both expressions. So you are going to have 5 outside the bracket, and what is inside is x to the power 4 minus y to the power of 8. Now the next thing that you will notice, or you will have to remember when you're talking about the exponents, is the 4 and the 8, as well as the negative sign, and you'll pick that it is a difference of 2 squares. Now if I continue with that, I'm going to have 5, I'm going to open 2 brackets, remember difference of 2 squares, so I'm going to have x squared minus y to the power 4, and I'm going to have x squared plus y to the power of 4. Here the exponents I divided 4 divided by 2 and 8 divided by 2. I got a 2 and then 4. Furthermore, you also pick up the same thing again where there is a negative. Remember, difference of 2 squares, there must be a negative. There is a 2 and there is a 4. If I divide again, I'm going to have here a 1 and a 4. So I'm going to have 5. Again, if I do that, and then I'll have x squared plus y to the power 4. This is not a difference of 2 squares because the sign in between x squared and y4 is a positive. Now what I have here, I'll have x minus y squared, and then I'll have x plus y squared. Now with that, it provides you the question which says factorize the following as far as possible into prime factors, then that would become your particular answer. Now, how will they be marking you? Remember, each question is 3 marks. So the first thing that they will mark you is mainly these 3 brackets that you recognize, including the 5, of course. So taking out the 5, they could have given you a part mark, but the main one that they wanted you to check were the 3 brackets that they wanted you to come up with. Now, the next question that they asked is 15x squared y squared minus 25xy cubed minus 10y to the power 4. They want you to factorize as far as possible. So now when you look at this particular problem, what you need to pick out is to first focus on the numbers. You've got a 15, a 25, and a 10. Well, the signs are important, but in this case, the most important thing is to factorize what is common in these 3 numbers. And you can see that 5 is common in 15, 25, and 10. It is the highest common factor. The next thing is to look at the highest common factor of the variables, which is the x and the y. Now, in the first one, we have got an x. In the second one, there is an x, but in the third one, there is no x, which means x is not common. Do the y, there is y in all of them, the first, the second, and the third. So you take out the y. But now the question is, which power are you going to take out for y? Always take out the y when you're factorizing for the highest common factor. You look at the y which has the lowest power. In this case, the lowest power is a 2. So remember, when you're factorizing, it's like you're dividing. In this case, you're saying 5 into 15 in the first term. 5 into 15 is a 3, and 5 into x squared y squared, the y squared and the y squared will cancel, remaining with an x squared. We move on to the next term. 5 into negative 25 is negative 5. Y squared into xy cubed, the x will always remain, but there are 3 y's. 2 will cancel, remaining with a single y. Minus 5 into 10 is 5 into negative 10 is a negative 2. Y squared into y to the power 4, when they cancel out, 2y will remain, which is y squared. So now you have partly factorized. Yes, they will give you a mark, but this is not the end. You still need to take this further. Now, if we take this further, you are going to have 5y squared. You can come out with the factorizing, the normal factorization of product and sum. You are going to have 3x plus y, and the other one will be x minus 2y. Now, from this, then they are going to be able to give you your 3 marks, just like we did previously. Now, in this case here, they will mark you your 5y squared, your 3x plus y, your x minus 2y. Now, some of you will ask, where did I get the 3x plus y and the x minus 2y? So let me make a few notes here. Now, if you are going to do that, they are not going to penalize you by writing this. But now, let's look at this one. 3x squared minus 5xy minus 2y squared. Now, as I said, it's a product, it's a sum, and it's factors. So now, the product means times, the sum means plus, and the factors. The product, in this case, I multiply the first and the last expressions, and the sum, it is the center expression. This is the plus. So now if I multiply the product 3x squared minus 2y squared, I get minus 6x squared y squared, and the center one I will have minus 5xy. So I'm looking for 2 numbers. When I multiply them, I get minus 6, and when I add them, I get minus 5, and the 2 numbers are minus 6 and a positive 1. If I say minus 6 plus 1, I get a minus 5. A minus 6 and a 1 times 1, I get minus 6. Now, if I write them, this is how it will become. It will be 3x squared. Now, instead of this negative 5, what I'm going to have now is minus 6, but I just put xy because it's the placeholder there, is the variable that I must always retain, plus 1 xy minus 2y squared. Remember, this minus 6xy plus 1xy is minus 5xy. So if I continue, what is common in the first two is 3x is common in the first two. 3x into 3x squared is x. 3 into 6 is minus 2y, plus what is common in the last two, xy minus 2y squared is y. Again is x minus 2y. Now we can see now that we have got our x minus 2y. They are repeating in the two brackets. As you can see them here, x minus 2y, x minus 2y. And outside the brackets, what do I have? I have got 3x plus y. Now as you can see, outside the bracket, I've got 3x plus y. This is the same that I had as 3x plus y and x minus 2y. It is the product and sum method. Now, if you want to learn more about this method, there is a full video lesson that I did on product and sum in N2 and in N3. Now you can request more of these videos at a fraction of a cost, and then we'll send them to you. Now let us continue to look at the other question that were asked in the exam. Now we've done question 1.1. Now we're looking at 1.2. Now let us look at 1.2.1. 1.2.1. Now it says x squared minus y squared over x squared minus 2xy plus y squared, which is equal to, again, if you can study this carefully, you can see that the top, which is the numerator, is a difference of two squares, and the bottom, which is the denominator, you can also use the same method of the product and sum that we just described in the previous question. Now if you look at the top as a difference of two squares, you're going to have x minus y, and you write again as x plus y. After that, divided by, if you use the product and sum, you're going to have x minus y and x minus y. There are many ways of factorizing the bottom. I usually use the method called product and sum, but you can use any other method as long as you know how to factorize it, then it's fine. Then after that, we can cancel. You can see that x minus y will cancel with x minus y. Now what's remaining here is x plus y over x minus y. Then this becomes the final answer to that particular question. Now again, on the mark allocation, what they're going to be marking you mainly is, did you manage to factorize the top, and did you manage to factorize the bottom, as well as the final answer. Now let us move on to look at question 1.2.2. Now this question says 2 over a minus b divided by 4 over a squared minus b squared times 5 over 6a plus 6b. And now if you look at the mark allocation, is 4 marks. Now let's look at this. The first thing that you need to remember is to scan and look at carefully what is it that the examiner is trying to depict, or what is it that the examiner wants you to pick up. Now the first thing that the examiner wants you to pick up is that the denominator here is a difference of two squares. Now remember, a squared minus b squared, this is a difference of two squares. And also what the examiner wants you to pick up there is that 6 is common in 6a plus 6b, as well as what the examiner wants you to catch up or to pick up is that particular division sign. To say whenever you're dividing, if you want to change a division sign to a multiplication sign, the top, which is the numerator, will go down, and the denominator, which will go to the top, which is now the numerator. Now you remember, in other ways, you swap them. The 4 will go below, a squared minus b squared will go on top. Now we're going to put that all together into one solution. You're going to have 2 over a minus b. Now it's a times. Now a squared minus b squared goes on top, but as you say, it is a difference of two squares. Is a minus b, a plus b over the 4 that is now below, times 5 over 6 was common, and a plus b. Now when you have done that, the next thing to do is to check out when it's multiplication sign all across the board. Only if it's multiplication sign, then you can start cancelling. You can see that a minus b can cancel that a minus b. A plus b can cancel the bottom a plus b. The 2, they can cancel into 1, and 2 into 4 is a 2. So what is going to remain is equal to, in the first part, where there was a 2 is 1 times, where there was a minus b, a plus b, it all cancelled, a 1 remained, and then times 5 over, at the bottom, a minus b cancelled to remain with a 1, a 4 cancelled to remain with a 2, a 6 cancelled to remain, an a plus b cancelled to remain with a 6. So the final answer, you can use a calculator, you will prove that the final answer was a 5 over 12. Again, the mark allocation, it was a 4 marks question. The first thing they will check is you factorized well the top, you factorized well the bottom, as well as the whole cancelling. They will give you, when you're cancelling the top and the bottom, a mark, and the final answer is a mark. Then that becomes a 5 marks. Now the next question that they're asking, they're saying, if x minus 1 is a factor of f of x is equal to x cubed minus x squared minus 7 plus 6, determine the other factors. Now on this particular question, this is what I want you to note of. I'm going to do 2 methods, the simple one and the long division one. They are saying, in this case, I'll write in a different color. This is my f of x. My f of x is 2x squared cubed minus x squared minus 7x plus 6. This is what we're given as our f of x. Then they tell you that x minus 1 is a factor. When x minus 1 is a factor, it means when you equate it to 0, therefore x is equal to a 1. Now what I want you to note carefully for this quick method is, I want you to note the coefficients of the variables. In other words, the coefficient of x cubed is the 2. The coefficient of x squared is, there is a 1 there that is invisible, that you don't see, but you know that it's always existing. It's minus 1 x squared. The coefficient of x is minus 7, and the last number, though there is no x, it's x to the power 0, is a 6. So we're going to take in these numbers. What I'm going to do, right, let me give enough space. What I'm going to do now, I'm going to take the numbers 2 with their signs, minus 1, minus 7, plus 6. So when I get these numbers, you still remember x is equal to 1, so I put that 1 there. So the next thing I do is to start with this 2. I put it on top, which is my 2 there. The next thing, 2 will multiply 1. 2 times 1, which is 2, and 2 minus, I'm here now, 2 times 1, it's 2. 2 minus 1, which is a positive 1. I do the same thing again, what I just repeated. Now instead of a 2, now it's a 1 with a sign. It's 1 times 1, which is 1, and 1, I'm here now, minus 7. So it's 1 times 1, which is a 1. 1 minus 7 is a negative 6. I repeat again what I did in the first, the second, now is the third. But it's with the sign is minus 6 times 1. The 1 is always the first one. Minus 6 times 1, which is minus 6. Minus 6 plus 6 is a plus 0. Now, you must always get a 0 if it is a factor. If there was a remainder, the number that you get there will be the remainder. So now in this case, it's a factor, so there is no remainder. So what you're going to do, you're going to take the x minus 1. After taking the x minus 1, the next thing you are going to have is your 2 plus 1 minus 6. Now, this is what you do. Remember, the biggest power was a 3. Now you say 2, you subtract the 1, is now a squared. Followed by an x squared. Now in this case, it's just you subtract 1 is an x. So that is now your new f of x. So if you factorize, this is, in other ways, your what? Your f of x. Now if you continue, what we're going to have now is to factorize 2x squared plus x minus 6. So using again the product sum, if you factorize 2x squared plus 1 minus 6, we are going to have, in this case, we are going to have x minus 1. When you factorize this part, we are going to have 2x minus 3, and we are going to have x plus 2. So the other factors, remember the question says if x minus 1 is a factor of that, determine the other factors. In this case, the other factors, then you can see them are 2x minus 3 and x plus 2. Those are the other factors that they were referring to. Now, as I said, let me now use the long division method. The long division method is the one that is properly taught when it comes to most places, but still, as I told you, you can always do the faster version that I showed you if you practice it well. Now let's look at the long division method. Is x minus 1. We have got 2x cubed from the question minus x squared minus 7x plus 6. So we're going to do the long division one. Now the long division says x into 2x cubed, it's 2x squared. 2x squared times x, it's 2x cubed. Again, 2x squared minus x is minus 2x squared. Right? You roll off, then put a bracket because you're going to subtract. 2x cubed minus 2x cubed, you're going to get a 0. X squared, not x squared actually, it's a negative there, minus x squared minus 2x squared. You can see that there is a negative there, there is a negative, and there is a negative. So here be careful, minus x squared minus 2x squared, you're going to get a positive x squared. You need to know your algebra. Now after that, what you're going to do is you're going to bring down this particular negative 7, so it will become minus 7x. Again, you repeat the same step. X into x squared, it's a positive x. X times x is x squared. X times minus 1 is minus x. You roll off, you put a negative and put the brackets. X squared minus x squared, you're going to get a 0. Minus 7x minus x, you're going to get a positive 6x. When you get that positive 6x, what you need to do is to bring down the 6 with its sign, which will become a positive what? 6. So what you have now, you're going to have x into 6 is a positive 6. 6 times x is 6x. 6 times minus 1 is minus 6. Again, you're going to roll off and subtract. So you're going to have 6x minus 6 is a 0 plus, am I right here? Let's recap. I think there is an error here on the signs. We said, let's come back to the top here. I think we missed something there on the negative. We said minus 7x, it was x squared minus x squared is 0. Minus 7x minus x is not a positive actually, it's a negative 6. So it's negative 6. After that, you bring down a 6. So after bringing down a 6, x into minus that is not a positive. We have to correct that. It was a negative 6. Please correct that. Minus 6 times x, here we still have a negative 6. Can erase that part. Now as we're multiplying, minus 6 times x is minus 6x, minus 6 times negative 6 is plus 6. Do the same thing, put a bracket and subtract. Minus 6 minus minus 6 is 0, plus 6 minus 6 is a 0, because if you're going to get a different number from this, like a remainder, it means it was not a factor, hence I picked it up quickly that something went wrong and it was those negative signs. So please go again and check carefully, it was an issue of the negative. Now when you have done that, what you are having now is f of x is equal to x minus 1, and what is on top there, the quotient is 2x squared minus x minus 6. As you can see, we've divided, which is in this case similar to the 2, 1 and minus 6, which you said was 2x squared plus x minus 6. If you can refer to these two methods, you will see the pattern, but that other one was a quicker method. Now back again to 2x squared minus x minus 6. Remember, when you factorize it, you'll discover that it's x plus 2 and 2x minus 3. So now you're going to have f of x now being x minus 1, x plus 2, and x minus 3, and the other factors are these two other factors. So this is the way you could have solved this particular method. So this was our question 1.3. Now let's move on to the next question, and the next question is question number 2. Now when you look at question number 2, we are now not simplifying, we are now solving for x. Now we're still in algebra, but in this case we're solving for x. Now the first question that they are bringing there is you have to solve square root of 10 minus 3x minus x is equal to negative 2. Well, it's not a difficult method. It's something that the examiners like asking on this particular question 2.1, and I want you to be careful whenever you're doing it. So let me try to solve it in this space. It says square root of 10 minus 3x minus x is equal to negative 2. Now, one thing you have to get rid of is on this other side is that negative x. Make it jump the equal sign so that you have got square root of 10 minus 3x is equal to, it's negative, the x is negative, it will become x minus 2. Now the next thing is to get rid of the square root. And how do you get rid of the square root? If you are given a square root on the other side and you want to get rid of the square root, the principle says you must square both sides. That's how you get rid of the square root. What you do on the left, you must also do on the right. So what you have here is x minus 2. So you square on the left, you also square on the right side. Now the square root will fall off, it will become 10 minus 3x is equal to x minus 2 and x minus 2. Remember, it's a square, which is 10 minus 3x will be equal to, if you expand, it will be x squared minus 2x minus 2x plus a 4. I just want to give it space like that. When you have done this, the next thing to do is to collect your like terms. When you're collecting your like terms, you're going to have x squared minus 2x minus 2x, and then you can see that 10 must join, 3 minus 3x must join also, you to become a positive 3x. After becoming a positive 3x, you have got plus 4 minus 10 equal to a 0. That will be equal to 0 because of space. Now we'll write it in the next place. Now what we have again is x squared. If you solve this, minus 2x plus 3x, you'll get that you are having minus x Again, 4 minus 10 minus 6 is equal to a 0. Now I'm putting the 0. Using again the factorizing of the product and the sum, we're going to have here is x minus 3, x plus 2 is equal to a 0. Therefore, x minus 3 equal to 0 and x is equal to what? A 3. That's the first solution. X plus 2 is equal to a 0. It means x is equal to negative 2. So those are the two answers that are given. But now you need to check whether both answers are a solution to that particular problem. So what you do is you come and prove. How do you prove? I'm going to make in small writing just to prove both answers. I go to the top one. Remember, it was square root of 10. I'll start with 3. So it is 10 minus 3 bracket. I'm starting with the first when x is 3 minus 3. It must give me a what again? A negative 2. Let's check it. If you use a calculator, 10 minus 9, which is a 1. 1 minus 3. 1 minus 3 is equal to minus 2. So this solution is correct. So the first solution is x is equal to a what? A 3. You try the second one. Square root of 10 minus 3. Remember now the second one is x is negative 2 minus bracket minus 2. Again it must give me a negative 2. So what is 10 minus 2? We are getting a 16. Square root of 16 plus 2 is equal to a negative 2. Now the question is, what is square root of 16, which is 8? 8 plus 2, which is 10, is equal to negative 2. And you know that 10 cannot be equal to negative 2. So therefore this means x, in this case that's what you do. You say x is not equal to minus 2. So the only solution here is x is equal to 3. Don't forget that if you leave your answer just as x is equal to 3 and x is equal to minus 2, you are going to lose marks. You're not going to get your 4 marks because one of the answers is not a solution because it does not balance as an equation. Now that was our 2.1. Let us look at 2.2. Now 2.2 is the question here says you have to simplify. Those are exponents. 2 to the power 2x plus 2 minus 2 to the power x minus 1 is equal to 56. Now for this particular problem, you're going to get 4 marks. Now let's look at it. Now the first thing to do is to split these into their product. Now 2 to the power 2x plus 2, remember, according to the laws of exponents, is 2 to the power x dot 2 to the power 2 minus 2 to the power 2x dot 2 to the power negative 1 is equal to 56. Now the next thing then that you need to do is to factorize on the left hand side 2 to the power 2x. You can see you have got 2 to the power 2x, you have got 2 to the power 2x. So if you take it out, 2 to the power 2x, what you have inside is 2 squared minus 2 to the power negative 1 is equal to 56, not 52, 56. When you have done that, the next thing that you need to do is to divide both sides by 2 to the power 2 minus 2 to the power negative 1. 2 to the power 2 minus 2 to the power negative 1. When you cancel, you are going to have 2 to the power 2x is equal to, if you use a calculator, it will give you a 16. After that, 2 to the power 2x is equal to 2 to the power 4. Therefore, it means according to the laws of exponents, when bases are the same, you equate the exponents. Therefore, what it means, 2x is equal to 4. With that, you divide by 2 on both sides. It means x is equal to a 2. Now you can also check your answer, but this is not necessary in the final exam, but you can say test. In this case, we are going to put your 2 to the power 2, 2 plus 2 minus 2 to the power 2, 2 minus 1, it will give you a 56, meaning your solution is correct. Now, if you look at that, the next question, this was 2.2, this was our 2.2. Let's go to our 2.3. With question 2.3, it is centered on the logarithms. So I've copied again this question. It says 2 log base of x of 4 plus log base of x of 54 minus log base of x of a half is equal to a 3. Now you have to simplify that. Now remember, according to the laws of logarithms, again in a N3 maths they provide a formula sheet. Now in that particular formula sheet there are laws that you can refer to the laws of logarithms, refer to the formula sheet. You will see that the laws of logarithms they are applicable in this particular case. Let me try to show you the laws. So in this case, the laws, you can see we can use 2 different laws. There is this law that it says log a to the power m is m log a, but we are reading this law in this direction whereby it's m log a is a to the power m. So there is a 2 there, we have to take the 2 as a power back. And then also we're going to use law 1, whereby when logs are adding, log a plus log b is equal to log ab. So log 4 plus log 54 minus log, now the minus part is log a minus log b, which means we're also going to use this law. So 3 laws are being applicable here, which is law number 1, law number 2, and law number 4. When we put on these laws all together, we are going to be able to solve this. Now if I erase that and bring back the way, so we are going to have now log in base x. Remember, this is 4 squared, the 2 is now becoming a power, plus log base x of 54 minus log base x of a half is equal to a 3. Now applying the laws of addition, when logs are adding and they are subtracting, we are going to have log in base x, just to have a proper x there, putting a bracket. Now what is 4 squared? Remember 4 squared is 16. Now because they are adding, say 16 times 54. Now minus, it means you're dividing by a half, is equal to a 3. That is the best way. If you use a calculator, you are going to get log in base x. Now if you do 16 times 54 divided by a half, you are going to get, if I use a calculator, punching a calculator there, is giving me 1728 is equal to a 3. Now when I'm done that, still using the laws of logarithms, it says x to the power of 3 is equal to 1728. Now how do I find my final answer? It will be x to the power of 3, I multiply times the power 1 over 3 is equal to 1728. I also multiply it by a power 1 over 3. Remember, there's a power. Now if I again use a calculator, in this case this 3 and this 3 will cancel. I'll get my x is equal to, use a calculator, 1728 to the power 1 over 3 will give you x is equal to a 12. Again, you can substitute where there is a x, you put a 12, a 12, a 12. If you put it in your calculator, you'll discover, please use a scientific, usually a Casio calculator. If you put the 12 there, where there is x in this basis, it will give you an x is equal to 12, just to prove that your answer was correct. So this is the normal way you could have done these logs. Or alternatively, maybe just quickly, from this stage where I'm just following up on that method, remember we had log x, it was 4 squared, which was 16, plus log base x of 54. Now minus, I can always choose to say, remember there was a half, but I can say a half is same as log 1 minus log in base of x of what? Of 2. But don't forget to put a negative sign in the bracket. So this is same as log in base of x of 16 plus log in base of x of 54 minus log in base of x of 1 plus log in base of x of 2. Now this log base x of 1 is a 0. Any base log base x of 1 is a 0. Base log 1 is 0. Log 1 whatever base is 0. So in the final we are going to have log base x. Again, now the numbers, everything is multiplying because it's a plus. 16 times 54 times 2. Remember this was 3, this was equal to 3, and the previous one is equal to 3. Now we're back to say log 1728 is equal to 3. Same thing, back now to say x to the power 3 was equal to 1728. Now in this case, some people prefer to, instead of cube root, they prefer to do this, to say cube root, do this, to say cube root. You find the cube root of x. What is cube root of x cubed is x. Cube root of 1728 is equal to 12. So these are different ways you could have done on the same question. Now we are moving on to look at another question again. We're looking at now question number 3. Now in question number 3 it says John runs from A to B uphill with an average speed of 8 kilometers an hour and returns from B to A downhill with an average speed of 12 kilometers an hour. What is his average speed during the total distance? So in this case now, maybe if I can try to draw a scenario of what's happening here. Remember this is 3.1. Let me just try to draw a scenario here like this. We've got 2 points. Here you've got point A. Here you've got point B. Now John is running from A to B and they're telling us it's 8 kilometers an hour. And also on the back trip, John is running from B to A and they're telling us now he's running faster. He's running now at 12 kilometers an hour. Now the question says then, what is his average speed during the total distance? Now they're saying hint, distance is equal to average speed times time. That hint is very important. But now let us write a few things that are important for what John is doing. Let's say take the time taken from A to B. Let's say the time taken from A to B is a capital T. And then let's also assume time taken from B to to A, remember you changed speed, let's use a small t. And then, now what is total time taken? Which means total time taken then is what? Is t plus t. Remember, time taken from A to B is a t, which is the capital T. Time taken from B to A is a small t. So now if you want to find the total time taken for the whole journey going to B and coming back to A is a t plus t. Let's hold it like that. We'll come back to this. Now, let's focus on the distance. Distance from A to B. Now, remember, they gave us a hint. They said, hint, distance is average speed times time. So, distance from A to B, what is the speed? Average speed is 8 kilometers. And the time from A to B, we said is capital T. So, distance from A to B is average time 8 times T, which is equal to 8T. And then distance from B to A, using the same method, it is 12 with a small t. Now it's 12t. Remember these two. Now, so the distance is 8t and the other distance is 12t. Now, having that, let's look now, how do you calculate the average speed? Now, I'm using my red now because I'm going to the solution now. Average speed for the whole journey now. This is whole journey. Alright, is equal to total distance over total time, or total time taken, which is equal to, I'm gonna solve that for space. Now, total distance, remember distance from A to B is 8t plus what again? 12t over total time taken, we say it was a t plus what? Plus t. Remember that. But there is something that we know, but distance AB is equal to distance BA, because it is the same distance that was being traveled. Distance to AB is the same as distance BA. So what does it mean? It means this distance AT is equal to 12t, because that's the distance from A to B is equal to distance from B to A. So I can make the other t the subject of the formula. So now what do I have? I have the big T is equal to, if that is simplified, or without simplifying it's still fine, I'll have 12t over 8. So that is my big T. Now if I put it now in my average speed, what I'm going to have is average speed is equal to, now remember it was 8t plus 12t. Now it's the same speed, it is, let me write it, 8t plus 12t over t plus t. This is same as, remember the distance on top is the same, it's same as saying 12t plus 12t over, now the big T, as we simplify it, is 12t over 8, so which is 12t over 8 plus t. Now if you simplify, you are going to get 12t plus 12t is 24t over 12 over 8. You are going to get 5 over 2t. If you add the bottom and the top, if you add the 12 over t plus t, you get 5 over 2t. Then if you simplify that, the t is going to cancel out, and the total distance that you're going to get now, if you divide these, you're going to get 9.6 kilometers per hour. So now it means the total distance traveled is 9.6 kilometers an hour. So again, it was not that difficult, but it needed you to be a bit sensitive to a few things. Now the other question that they brought here was make R the subject of the formula. Now they are looking about the subject of the formula. Make R the subject of the formula in the given expression. So it's B is equal to A over square root. The square root is affecting R squared plus P plus Q. So if I can write it, that was question 3.2 there. They are saying B is equal to A over, remember it was something like this, R squared over P plus Q. As I said, the square root is affecting both R squared as well as PQ. Now the first thing, or the first concept that you must always remember is to get rid of a square root you must square, but whatever you do on the left you do on the right. So we can do it like this and say B squared is equal to A over R squared plus PQ in a square root squared. Now when you square like that, each one will be affected. The numerator, which is A, will be affected separately, and the denominator, which is the bottom, will be affected separately. So you're going to have B squared is equal to A squared. You can see it's affected over, but now R squared minus PQ. There is no more any need for the square root. Now this is like B over 1, and then it cross multiplies. When you cross multiply, what you're going to have, remember you're looking for R. So when you cross multiply, you're going to have B squared multiplying R squared minus PQ is equal to A squared. Now the next thing, it's up to you how you want to do it. You can first expand this bracket, or you can divide by B squared first. Whatever you do, it will still bring out the same answer. The aim is to make sure that you get R alone. So for argument's sake, let's say we are going to expand the bracket. So if you're going to expand the bracket, I'm going to have B squared R squared minus B squared PQ is equal to A squared. Then I'm going to take B squared PQ to the other side. It's negative, it will become positive. So I'll have B squared R squared is equal to A squared plus B squared PQ. Then after that, the next thing I'll need to do is to divide both sides by B squared, both sides by B squared. If I do that, I'm going to have R squared is equal to A squared plus B squared PQ over B squared. Now remember, I must remain with R on as the subject of the formula. So what do I do? For me to remain with R, I must square root R. That's how I get rid of that. But what you do on the left, you do on the right. So it is A squared plus B squared PQ all over B squared. This must be all in the square root. So now my final answer will be r is equal to, some they prefer to put a plus or minus, because a square root you can always put a plus or minus. It's a squared plus b squared pq over b squared. That is the solution for the difference of two square, for the subject of formula for the given expression. Now moving on, the next question that is coming out here is determine the value of x by means of completing a square. Determine the value of x by means of completing a square. So now what are we given? We are given that x squared is equal to minus 6x plus 5. Now remember, whenever you are completing a square, you must follow the principles of completing a square. So now what you do first is to take this negative 6x back to join the x. It will be a positive 6x is equal to a 5. And then when you have done that, now let's complete the square. It's x squared plus 6x plus half the coefficient of x, which is half of 6. And then what do we do? We square it, which is equal to 5. What you do on the left, you do on the right. Plus half times 6 is squared. Now this is same as if you simplify what you just half times 6 squared. It's like you have got x squared plus 6x plus 3 squared is equal to 5 plus 3 squared. And then when you continue now, we are going to have x plus 3 squared in essence is equal to, using a calculator, you're going to get 14. Now how do you simplify that? You square root both sides. X plus 3 squared is equal to square root of 14. But remember, whenever you're doing that, you must say plus or minus square root of 14. Now to write your final answer, it means x, I can write the final answer so that I don't mess up. X plus 3 is equal to plus or minus square root of 14. Therefore x is equal to minus 3 plus or minus square root of 14. This is what they mean by solving for x by means of completing a square. Now you get your 4 marks for that. That was the question 3.3. Moving on to 3.4. Now with question 3.4, it says determine the quadratic equation of which the roots are x is equal to half and x is equal to 2 over 3. Now with that one, there are many ways you can do it, but there is a simple version that you can always follow. They are giving you that x is equal to 1 over 2, and then they are also giving you that x is equal to 2 over 3. Now the common thing, what you need to do is the 2 will multiply that x, so what you're going to have is 2x. The 1 will jump the equal sign there, is minus 1 as the first one. Even this one again, the 3 will multiply the x, the 2 will jump the sign, it will become 3x minus 2. So when you look at these in brackets from, you have got 2x minus 1 and you've got 3x minus 2. So now if you expand that, 2x times 3x, it's 6x squared minus 4x minus 3x plus 2. Then what you have, which is equal to 6x squared minus 7x plus 2. Now what was the question saying? Determine the quadratic equation for which the roots. So this is the quadratic equation. Now in this case, you must say that must be the one equal to 0, because it's a quadratic equation. That is equal to 0. So when you solve it, it will give you x is equal to half, or x is equal to x is equal to half, or x is equal to 2 over 3 when you solve it. Now, because of my space, let me show you a simple alternative method that also you could have done. But I'm gonna do it as fast as I can. Now, as I said, it was x was equal to negative half, and the other one was x is equal to, not negative half, it was x is equal to half, x is equal to 2 over 3. Now, the thing is, take all of them on the other side of the equal sign. You've got x minus half equal to 0, and then x minus 2 over 3 equal to 0. So you take that in brackets, x minus half, x minus 2 over 3, this is equal to 0, and then you start to expand. X times x, this is x squared minus 2 over 3x minus 1 over 2x minus 1 over 2 times negative 2 over 3 is equal to 0. So you have got now x squared. If you say minus 2 over 3 minus 1 over 2, you get minus 1 over 6x. And you come here, you see cancel. The negative becomes a plus, and it becomes plus 1 over 3 is equal to 0. Looking what is common here between 6 and 3, it's 6. So you multiply everything by 6, which is 6x squared minus 6 minus 1 over, it's a plus 1 over 6x plus 1 over 3 equal to 0, which is 6x squared. You multiply there, it's minus x, 6x squared. I think I forgot 1 here. It's 6x squared. As a correction, there is supposed to be minus 7 over 6. It's 7 over 6, so it's minus 7x. Minus 7x plus 2, which is equal to 0, which is similar to the previous one that we just did. So this is another alternative method. Now let us move on to question number 4. It says, in figure 1 below, ABC is a triangle with vertices A is equal to 8, 0, 8, B, 1, 0, C, 4, 0. So you've got these vertices. You can see there is your A, there is our B, there is our C. BD is a line. Where is BD? There is BD line there. Drawn with D is PQ. There is our D there. And AC makes an angle of 45 degrees with the x-axis. Where is AC? And then it says DP on AC. It says BD, a line with DP on AC, makes an angle of 45 degrees with the x-axis. As you can see, there is that particular angle that they're talking about, the 45 degrees. Now, having studied that, let's look at the questions. It says determine the following. 4.1, it says the gradient of BD. Now, if we are to look at the gradient of BD, now BD is the same one that they say BD had an angle of 45 degrees. Now, if I can pull out the formula sheet, as you can see there, I'm using the formulas, and then there is this one which says angle of inclination says theta is arctan minus 1 m. So in other ways, sometimes it's written as tan theta is equal to m. That's another version of that. So if you can use that one, we're going to solve it for the next question that we're asking. So now, what we have now, they told us that theta, in this case, was equal to 45 degrees. That's why it's 1 mark. So you just say tan theta is equal to m. In this case, tan 45 is equal to m. If you punch it, therefore, m is equal to, if you punch tan 45, you're going to get a 1. But this is the gradient of BD. So some they write it like this: m of BD is equal to a 1. So m of BD is equal to 1. So remember that. Now the next question says the value of P. Now how do we find the value of P? We've got our B as 1, 0 from the previous one, and we've got our D. What is our D again? Our D was P2. Now for that one, let's look at gradient of BD. Remember, gradient of BD is 1, but we know how to find gradient. M of BD, given those 2 points, is equal to y2 minus y1 over x2 minus x1. You can choose whichever point you want it to be x2. So I'll make the D being the 2's. So this is the same as 2 minus 0 over P minus 1. This is equal to 1. Why? Because BD is also equal to 1. So M BD is equal to that, which is equal to a 1. Now when I solve it, remember this is same as over 1. I cross multiply. Now 2 minus 0 and P minus 1. So I've got 1 multiplying P minus 1 is equal to 2 minus 0, which is 2, multiplying a 1. So 1 multiplying P minus 1 is same as P minus 1 is equal to a 2. When it jumps the sign, it will become P is equal to 2 plus 1. Therefore, P is equal to a 3. So in this case, P is equal to a 3. And the question says, determine the value of P. The next one says, the length of AC, leave your answer in its simplest set form. Now, if they want the length of AC, now going backwards, if you can check again, what was our coordinates for A? A is 0, 8 and C is 4, 0. So if you can write that. But before that, now how do we calculate the length? You have to go to the formula sheet and then you can see how you calculate the length. It says D is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. That's how you calculate the distance. So using that formula for distance, now again remember we've got the two values of A from 0, 8 and also C, it was 4, 0. Now D of AC is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. Everything must be under a square root. It's up to you which one you make your x2, which one you make your x1. It does not make any difference. I'll make my second become my x2. So it will be 4 minus 0 squared plus 0 minus 8 squared. As I said, it doesn't matter which one you start with, the answer will be the same. If you punch your calculator, you don't need to work this one. It will give you a 4 root 5. So the moment you get that, it's your final answer, and you will get, see how many marks? It will give you 2 marks. The next one is the gradient of AC. Now let's look at AC again. If you look at AC, if they want the gradient of AC, you can see that you know point A, you know point C. So you can simply calculate the gradient of AC without a problem. So now I'm going to use the same page because here we're still having AC. So now m of AC is y2 minus y1 over x2 minus x1, which is equal to, my second is my 2, which is equal to 0 minus 8 over 4 minus 0. If I look at that, the answer therefore is equal to negative 2. Therefore, m of AC is equal to minus 2. These were given marks that they were giving there. They were not difficult. Then the last one is, on this question, the size in degrees of an obtuse angle theta between AC and the x-axis. Now, let us look at that. The obtuse angle, this is the one they were talking about, between AC and the x-axis. So they wanted to find that particular theta. Now, you go back to the formula that we said, we showed you. I'm working on the previous solution. It says theta is equal to arctan m, but you know that m of AC was equal to negative 2. So theta is equal to arctan negative 2, and then the answer that you get is 63.43 degrees. Now, because the answer that you got was negative, what you need to do, you say theta is equal to 180 plus minus 63.43. Remember, they said obtuse. And then using your calculator, you will get 116.57 degrees. That is the answer that they wanted. Sometimes you can always forget this particular sign and you focus on 63.43 because they said obtuse. Obtuse is always 180 minus 63.43. You're still going to get the same answer. Now, that was question 4.5. You get 2 marks. Now, moving on, let's look at 4.6. Now, looking at 4.6 says the equation of the line parallel to AC passing through point B, leave your answer in gradient intercept form. Now, don't always be confused with this gradient intercept form. It's y is equal to mx plus c. So they're saying the equation of a line parallel to AC passing through point B, leave your answer in gradient intercept form. Now, the equation of a line parallel to AC. Now, let's go and look at AC. So, if something is parallel to AC, it means, remember the same gradient. Parallel lines, there is this concept M1 is equal to M2 for parallel lines. So, parallel lines have got the same gradient. So, they want the equation of a line parallel through AC passing through point B. So, there is a dotted line there. It passes through 1, 0. So in this case, what you are given is that you are going to have, the first thing that you are going to have is, you are going to have the gradient m of AC. We did find it, it was minus 2. They said it passes through point B, and you know point B is also given as 1, 0. So now there are 2 ways that you can solve this. The simple one is saying y is mx plus c. Now, with y is equal to mx plus c, now this point B will give you y as 0 is equal to m minus 2, your x is 1 plus c. Now, you find that therefore your c is equal to a 2. Now, if you write it in gradient intercept form, y is equal to m, which is minus 2, x plus 2. That is the answer. Sometimes you can use that formula, y minus y1 is equal to m x minus x1. This is another formula. Now you know the y is 0. Y minus 0 is equal to, the gradient is negative 2 x minus 1. So y is equal to, multiply that, minus 2x plus 2. This was the same answer that you could have brought. The next one, 4.7, says the equation of a line perpendicular to BD passing through point B, leave the answer in gradient intercept form. Now, there is something that they are bringing again about BD. if you still remember about BD, what we noticed with BD is that we know the gradient of BD. The gradient of BD was given in the first question as 1. So they're saying the equation of a line perpendicular. Now, perpendicular lines, you must remember M1 times M2 is equal to minus 1. This is for perpendicular lines. The first one was for parallel lines. For M1 times M2 is equal to minus 1. So they're saying the equation of a line perpendicular to BD. And then, what is the other thing? Passing through point B. So now, we know point B. If I can go to the equation of a line perpendicular to BD, passing through point B, leave your answer in gradient intercept form. Now, point B is always 1, 0. Now, perpendicular lines, I'm going to answer it here also. Perpendicular lines, remember, M1 times M2 is equal to minus 1. We know the gradient of BD was equal to 1, so M1 times 1 was equal to minus 1. So M of perpendicular there is negative 1. Now it passes through B using the formula y minus y1 is equal to m x minus x1. Now I'm solving, just not to confusion, is question 4.7 here. So now y minus 0, because we're using the same coordinates of B, is equal to m, which is minus 1, x is 1 minus x, sorry about that, let me correct this, is equal to mx minus 1. So y is equal to minus x plus 1. You can use the previous method I started with. It will also give you the same answer. So now you can see now this was the analytical geometry that they wanted you to capture in this case. Let us continue to look at question number 5. Question number 5 says 5.1. If you start with 5.1, it says draw the graph defined by x squared over 25 plus y squared over 4 is equal to 1. This is 3 marks. Now if you look at this graph, you will discover that it is an ellipse. So now if we go and look, if we can draw this particular graph can quickly work on it. It's x squared over 25 plus y squared over 4 is equal to a 1. Remember, this is same as x squared over 5 squared plus y squared over 2 squared is equal to a 1. So now, simple by looking at this graph, it means x will be equal to plus or minus 5 and y will be equal to plus or minus 2. So now it means there is a point in 2, there is a point in minus 2, there is a point in minus 5, and there is a point in 5. So now what you need is to draw an ellipse. So that is the graph of x squared over 25 plus y squared over 4 is equal to a 1. So that is the ellipse. Let us move on to the other question. It says given that f of x is equal to it's x cubed minus 12x squared plus 36. Determine the coordinates of the turning point of f of x. So now if you look at that one, again when you look at it, it says 5.2.1, it says determine the coordinates of the turning points of f of x. But remember, when they're talking about the coordinates of the turning point, it means you have to find the x coordinate as well as the y coordinate. And also remember, this is a cubic function, which means there are two values where this graph is turning in terms of the x value and the y value, which means you're going to find two coordinates of x and two coordinates of y where this particular graph is turning. It is a cubic graph. So now if you look at that, the first thing that you need to remember is you have to find the dy over dx, or you have to differentiate this graph. F prime x is equal to, it's 3 times 1 x 3 minus 1 minus 12 times 2 x 2 minus 1 plus 36 times 1. Now these are the laws of differentiation, which is 3x squared minus 24x plus 36. As I say, these are the laws of differentiation. Now the next thing that they need you to remember is to write this point at turning point f prime x is equal to 0. That is very important. At turning point f prime x is equal to 0, meaning that 3x squared minus 24x plus 36 is equal to 0. So we can see that 3 there is common. You can cancel out the 3. 3 into 24 is 8. 3 into 36 is a 12. 3 into a 0 is a 0. So now we are going to have x squared minus 8x plus 12 is equal to 0. Now when you've got that, you have to factorize. When you factorize, just like we were factorizing before, is x minus 6 and x minus 2 is equal to a 0. Therefore x is equal to 6 or x is equal to 2. So these are the first values of x. And now, as I said, you're going to get two values for x as well as two values for y. Now the question says determine the coordinates of the turning point. So this is not the end. So now if I can divide this page, now let's look at the y values. So the first thing is when x is equal to 6, what happens? You have to find the y value. So you're going to substitute in the original equation, which is f of 6 is equal to 6 cubed. Remember, this is the original equation, minus 12 6 squared plus 36 6. If you punch this in the calculator, you are going to get a 0. Now, which means when x is equal to 6, y is equal to 0. Let's do the last one again. When x is equal to a 2, now you're putting, instead of 6, f of 2 is equal to 2 cubed minus 12 2 squared plus 36 and 2. And when you do that, you'll get that x is equal to 32. Now let us look now at the coordinates here. What are the coordinates? At turning point. So these coordinates, remember, when x is 6, what is y? Y is 0. And when x is 2, y is 32. So these are the coordinates that they were requiring. So that is the final answer. Then you'll get 4 marks for that. But where are the marks distributed? You can use a different mark. They will give you an answer for finding the x values. They'll give you an answer for finding the y values. Two of them. They'll give you an answer for finding the y values, two of them. For finding dy over dx, you'll get an answer there, and equating it to 0, you will get an answer. So this is not basically finding the final solution, but it is the working through. Though the marks were a bit stiff in terms of few marks were given for this one, but this is the solution for that particular question. Now looking again at the next question, it says calculate the x and y intercepts of f of x. Now if you look at that next question, it says calculate the x and y intercepts of f of x. The first thing that you need to look at, that is 5.2.2, is to write the statement again. At x-intercept, y is equal to 0. That is, remember that. So at x-intercept, y is equal to 0. But what are you given? You are given that x cubed minus 12x squared plus 36x. Therefore, this one will be equal to 0, because in other ways, here it's same as if it's y is equal to 0, it's same as f of x. You must equate it to 0 at x-intercept. After that, you have to solve for x. I'm going to factorize x because x is common across. It's the smallest power for 36x. So here I will have x squared minus 12x plus 36 is equal to 0. Now this is solving, it's algebra. Now this means x is equal to 0 or x squared minus 12x plus 36 is equal to 0. So now if you continue to solve that one, you're going to have, put it in brackets again. If you simplify it, you're going to have x minus 6. X minus 6 is equal to 0. Therefore, x is equal to 6. As you can see, this is twice. It's x is going to give us x is equal to 6 and x is equal to 6. So it will give us same answers twice. So that is the x-intercept. You continue again, the question says find the x and the y-intercept, and then you say at y-intercept, in this case at y-intercept, x is equal to 0. So remember those two, at x-intercept y is 0, at y-intercept x is 0. So when x is 0, it means f of x, if it's, remember f of x was x cubed it is f of x is equal to x cubed minus 12x squared plus 36x. Now when x is equal to 0, you'll discover that you're going to 0 cubed minus 12 0 squared plus 36 0. You are also going to get a 0. So now these are the intercepts. So the x-intercept, can finish up your answer like this and say x-intercept x is equal to 0 or x is equal to 6 or x is equal to 6, because they are twice. And y-intercept is y is equal to 0. What is an intercept? An intercept is where the graph cuts the x-axis as well as the y-axis. So that is what they needed when they were asking that particular question. The next question now, 5.2.3 says, sketch the graph of f of x and show the calculated values in questions 5.2.1 and 5.2.2 on the graph. Now, if we're going to look at that, they want us to sketch the graph and show the 5.2.1. In this case, this is the one. We're going to show these values that we're getting 60, 232, as well as the x is equal to 6, x is equal to 6, x is equal to 0, as well as y is equal to 0. Now, what I want you to remember also, when they say x is equal to 0, these are points like 0, 0, and these are points like 6, 0 in coordinate form, and for y it's also a 0, 0. You can see that 0, 0 is repeating on the intercept. So now, if we are going to sketch that point, I have pulled out my graph there. Remember, this is my y, and this is my x. Now, the first point that you must remember is that we had a point here, and that particular point was 0, 0. So I'm going to put it in coordinate form. It's 0, 0. And then the next point that I want to choose, if I can mark, is this point here. I can make it 6. So in this point it will be 6, 6, 0. And when I've made that 6, 0, this particular point here will be a 2. For my graph purposes, I'll make that point, if I still remember there was a 6, but I need the turning point. There was a turning point at 6, 0, which is happening twice, and 2, 32. So if I go to 2 here, I make it a 2 and a 32. So this is the first turning point. Just writing it in another pen. This is a turning point. Even here, there is a turning point. It's an intercept. If you look again at our solution, this 6, 0, it occurs on our intercept, as well as this 6, 0 occurs again on our turning point. So when a point is like that, it means this graph has got two ways. It is going to turn as well as cut. So now, if I'm drawing that particular graph, we are going to have a graph. Remember this, it is turning here. Need to have a nice graph. That is the graph. And then it is going to cut, but it must cut nicely on these intercepts. So when you're drawing your graph, make sure it cut nicely in the intercept. Then this graph is the graph of f. Now, what is it that you must remember here that they will be looking for? When they are marking you, they want to see this particular point. They want to see that particular point and that particular point. That's why they are giving you 3 marks for that particular graph. Now, let us move on and look again at the other question that they ask. That is now 5.3. It says determine dy over dx, that is still calculus, by using the rules of differentiation. The answer should be with a positive exponent and in set form where applicable. So don't forget that when you've differentiated using the rules of differentiation, that is not the final answer. The final answer, to get all the 6 marks, they gave a lot of marks for this one, there must be positive exponent and set form. So now, in this case, all of these f of x, they gave you in positive exponents, but they are not in set form because x to the power half was supposed to be square root of x. Now, let me rewrite this, and then we start to differentiate. Now, given this particular, you can see now the particular problem they have given you. Now for you to be able to differentiate, you must write these in a way that they will allow you to differentiate. Now you remember that using laws of exponents, 1 over x cubed is same as x to the power negative 3. By removing 1 over, you put a negative 3, minus 2 over 3, again x to the power half, if you take it on top, is x to the power negative half. So when you divide, you remove the division sign, you put a negative. Now if you apply the laws of differentiation, f prime x, now as a reminder, f prime x is same as dy over dx. So remember that. So with that, this is same as applying the law. There is a 1 already, so you drop a negative 3, x to the power minus 3 minus 1, minus 2 over 3, and then you drop a negative half, and x to the power negative half negative 1, which is equal to, please, if you have forgotten the rules of differentiation, again you have to go to the lesson. I have a lesson that I've done on calculus in N3. As I said, you need to request these lessons from the college. Send us an email after the lesson. I'll bring the details again so that you'll be able to get hold of the whole curriculum or the whole syllabus for N3 maths. Now as I said, if I can repeat, this one is minus 3. 1 times negative 3 is minus 3x to the power negative 4. Now if you look at the other one there, you cancel the 2, the negative and the negative, they will cancel to become a positive. So it will become plus 1 over 3 x to the power minus half minus 1 is minus 2 minus 3 over 2. Right? Now we come back to the question. It says leave your answer with positive exponents, number 1, as well as in set form. Now let's deal with the positive exponents. You can see that all the exponents are negative, so to put the positive exponents is minus 3 over, by putting the division sign you get rid of the negative exponents, plus 1 over 3 is already at the bottom, remember, it will join the x, which is 3 over 2. So these are the positive exponents. Now final answer, f prime x is equal to minus 3 over x to the power 4 plus, now there is something that you need to notice, 3 over 2, yes, it is in positive exponents, but it is not in set form. So this is same as 1 over 3, and then do that, this is 2, then x to the power of 3. Then this becomes the final answer when they say leaving your answer number 1 in positive exponents as well as number 2 in set form. So that was quite an interesting question. Now let us move on to the last question. The last question that they asked about this particular question paper that was written in April was on trigonometry. Now the whole of question 6 is focusing on trigonometry. The first question says 6.1, calculate the values of a that will satisfy the following equation for theta is less than or equal to a and a is less than or equal to 360. If I can work 6.1 here, so what I have is 4 tan a is equal to, minus 6 is equal to 0. In other words, 4 tan a is equal to 6. Divide by 4 on both sides. Tan a is equal to 3 over 2. Now when I've done that, I have to find a. Now with that, a is equal to arctan 3 over 2, which is equal to using your calculator, it's 56.31 degrees. But now you remember 10 is positive. If I can draw my Cartesian plane, 10 is positive. Remember, all students take chemistry. So what do you know? 10 is positive in the first quadrant as well as in the third quadrant, because they said between, remember the values are between 0 and 360. So here 10 is positive in two quadrants, which means the third quadrant is also A is equal to 180 plus the other value is 180 plus 56, the one that we got, 0.31. A will be equal to 236.31. Why? Because in the third quadrant is 180 plus theta. So that's why that theta is the one that was in the first quadrant. You say 180 plus theta. That second quadrant, the third quadrant is where 10 is positive. So that's why for this one they gave 4 marks. Now the mark here is for you to solve. After solving is for you to find the two values of theta. They can give a 2 mark for each, but 3 marks were sufficient for this one. But anyway, it is a 4 marks, which means you'll be given an extra mark. Either the first one can have 2 marks and then the other one will also have 1 mark, but the total of these is 4 marks. Now let us move on to 6.2. If you look at 6.2, it says simplify. This is 6.2. It says simplify the following. It says sine squared b minus sine squared b cos squared b. If you write that one, 6.2, you are simplifying sine squared b minus sine squared b cos squared b. Now if you have to simplify that, they gave 3 marks for this particular question. Now if you simplify, you can see that sine squared is common, so you will factorize your sine squared b. What you're going to have is 1 minus cos squared b. When you have done that, you now have to remember certain things, that cos, you can use another pen, cos squared theta plus sine squared theta is equal to a 1. So what is my sine squared theta? Sine squared theta is equal to 1 minus cos squared theta. The cos jumps the other side. So now using this concept, you will substitute it here again, which means sine squared b multiplied, so 1 minus cos squared b is on the same side, 1 minus cos squared, which is similar to also another sine squared b. Now if you simplify this, you will now have sine squared b times sine squared b is sine to the power 4 of b. Remember, like in exponents, a square and a square, there are 4 of them, then this becomes your final answer. So it wasn't really a big problem on that one. So you get your marks for that, which is they gave it 3 marks. Now let's move on to the next one. The other one says prove that sine squared b over 1 plus cos b is equal to 1 minus cos b. So if I can write it on the separate, it says prove that 6.3, prove that sine squared, this is a beta, like as an angle, over 1 plus cos beta is equal to 1 minus cos beta. What's the next thing to do is to choose which side you're going to focus on. So in this case, I'm going to focus on the left hand side. Now if I write the left hand side again, sine squared beta over 1 plus cos beta is equal to, now using the same, if I have my side note, remember cos squared beta plus sine squared beta is equal to 1, and what is sine squared beta is equal to 1 minus cos squared beta. They are just playing with the same version of that. So in this case, where there is sine squared beta, because I want to match it with the bottom, it becomes 1 minus cos squared beta over 1 plus cos beta, as you can see that. But also to remember, this 1 minus cos squared beta is same as 1 squared minus cos squared beta, which is in a way a difference of two squares, as you can see that, which is 1, I can maintain my pen, 1 minus cos beta, and the other one is 1 plus cos beta, all over 1 plus cos beta. As you can see now, there are some of the things are similar here, which is 1 plus cos beta and 1 plus cos beta, which is equal to 1 minus cos beta. Now what is 1 minus cos beta? We are back to our right hand side there, which is equal to our right hand side. So we have proven that sine squared beta over 1 plus cos beta is equal to 1 minus cos beta. So that is what they wanted as a proof. Now the next question that they are bringing there, as you can see, they are saying, consider figure 2 below. AB is a lighthouse of 100 meters. Now if you look at, consider the figure below. AB is a lighthouse of 100 meters away from a nearby building CD. So there is A, there is B, there is building C, and there is building D. The angle of elevation from the top of CD, there is the top of CD, to the lighthouse AB is 30 degrees. So I think they're talking about that angle. While the angle of elevation from the foot of the lighthouse, AB, so the foot is this one, to the top of the building, remember the building is CD, is 43 degrees. I think they were talking about that one. Determine the height of the lighthouse AB. Now they've given us 100 meters of BD, which is same as EC 100 meters, and they're also telling us that this angle is equal to that angle. So the only way they are trying to tell us is that these two lines are parallel, because these two angles are equal as well, which means we can come up with two diagrams. Now let's come up with two diagrams in this case. The first diagram that you can see, I'll go back again, is this one. Let me have it a bit low. I have that particular diagram, and 90 degrees here, it's 100 meters. Now which diagram am I drawing here? I am drawing this particular diagram here. So what I have is EBC. So I've got E here, I've got a B, and I've got a C. And remember, here is 43 degrees. Now the first thing that I want is to find EB. So how do I find EB? I say tan 43 is equal to opposite, which is EB, over adjacent, which is EC. So with that, 1043 is equal to, and EP is still EP over 100. So EP, therefore EP is equal to 11043. That's the first one. Now what is the next one? I'm also going to draw another shape. In this one, I'm going to draw this particular shape, AEC. So if I draw AEC, it is like this. It is like that. And then I've got my AEC. And remember, this is 100, and I've got a 90 degrees there. Now, the angle is 30 degrees. You can go back now. They gave us the 30 degrees. Why am I saying it's 90 degrees? The 90 degrees are these parallel lines. You can see that those will give you a 90 degrees. So, because it is a horizontal line that they drew there. And how do I know? And the fact that it is 100 meters as well as parallel, it means that that horizontal line is at 90 degrees. It's similar from the one that they brought at the bottom there. So if they are all parallel, if this is 90, it means also the other angles also 90. Now I want to find now AE. Again, I'll say 10, 30 is equal to opposite, which is AE over EC. So 1030 is equal to AE over 100. So AE in this case is equal to 110/30. Now, if you look at the final diagram, if I can do the final one now, remember the question says find AB. So what is AB in this case here? AB is equal to AE plus EP. If you add this distance and that distance, you'll get AB. So now we know AE, and we also know EB, which is AE is this one and EB is that one. So in other ways, we're going to say AB is equal to AE plus EB, which is equal to, what is our AE? If you look at it, AE, it was 110/30 and the other one is 110/43. So you are adding 110/30 plus EP, which is 110/43. If you use a calculator, you are going to get 150.91 meters, and then approximately that can give us almost 151 meters. So AB, the distance of AB is 151 meters. So that is one of the ways they wanted you to solve that, and they'll give you, it's a nice, I think it's 6 marks. Yes, it was 6 marks for this question, just that it didn't show well there. This question was 6 marks. So here you've got your 2 beautiful marks and your 2 marks for coming up with that, and then for solving it is that, and your final answer is that. Now the last question, as you can see, total is 100. The last question says draw the graph represented by the following trigonometric equation. Y is equal to sine x plus 1 with theta, where 0 is less than theta, less than or equal to theta, which is less than or equal to 360. Now let me draw a table so that I can fill in some values, and then we can draw the graph. Now again, the graph, remember, it's y is equal to sine x plus 1. As an example, the first one is when x is 0, you can say y is equal to sine 0 plus 1. Then you get the answer. If you punch a calculator, you'll get the value of 1. You move on to the second one. The second one will be y is equal to sine 30 plus 1. And if you punch a calculator, you're going to get 1.5. So again here, you have got 1.5. Now, I'm going to fill up the whole of this table because of time, but you can use your calculator. Let me fill up the whole of this table, and then we draw the graph. Now, if you look at these values, when x is 0, y is 1, for 30 is 1,5, for 60 is 1,87, for 90 is a 2, 120 is 1.87, 150 is 1.5, 180 is a 1, 210 is 0.5, 240 is 0.13, 270 is a 0, 300 is 0.13, 330 is 0.5, and 360 is a 1. Then what we are required is to draw the graph represented by that. Remember, it's from 0, that's why I started my values from 0 and until 360, and these are the corresponding y values. So if you had to draw that particular graph, so because of time, I've drawn up the Cartesian plane there. You can see these are the y and the x, and I've split my values in as much it's 30, 60, and then 30, 60, 90, 120, 150, 180, 210, 240, 270, this is 300, then 330 and 360. Now if I'm to draw my points, now if you remember, 0 was 1, so 0, when x is 0, it gave us, if I can also mark this side is a 1, this side is a 2. This side will be minus 1, this side will be minus 2. And if this graph was continuing also on the other side, on the left, you must also remember, it's also good to show this side is negative 30 to say that it can go on the negative side. So now if I can mark now these points, when x is 0, 1, there was a point there, and when 30 was 1.5, the center, I've got these points marked, so I'm going to just be quickly looking at them. 60 is 1,87, is a bit tricky, but 90 is 2. We can work with the numbers that are simple to look at. And 120 is also 1.87, you can leave it. 150 is 1,5, much better. And then 180 is a 1, simpler number there. And the other one, 210, is 0,5, which is here. 240 is 0,13, we can leave it, but 270 is a 0. And then 300, 0.13, we can leave it. 330 is 0.5, and 360 is a 1. I think you can see that there is a graph that comes out in a way. We can look at this graph. This graph is taking that shape. So that is the graph that they expected you to have, and this is the graph in which you are going to call it y is equal to sine x plus 1. Now as you can see, this graph, this is the 10, this is where this graph is got its equilibrium point. Remember, this is a sine graph, so it's turning about the line x is equal to 1, though you don't need to show that, but this is where this particular graph is turning. Now we have come to the end of our lesson. This was the last question where they were saying you have to draw this graph. So now, as I repeated again, this was the mathematics N3 for April 2018, the exam question paper and the memo that were provided. Now, for more information on these questions and the videos, as well as we supply the question papers with their memorandums, we have got a minimum. It's in PDF version, whereby each PDF has a minimum of 5 question papers between 2014 and 2016. For now, it has got its question papers and memos. We sell it at a fraction of a cost. So if you want to purchase these, please go to our website www.agrolentech.co.za, or you can send us an email to info@agrolentech.co.za, and we will send you an invoice with the payment option, how you can pay for these, so that we can email them to you. It is a PDF version. Also, our telephone number is included in that. Now, remember to avoid copyright issues. This is the property of Agrolentech College. Should you require more videos, we have got a full video of N3 mathematics with all the subjects, or with all the modules being taught. So you can request these videos and it will gladly help you. My name is Confident, and thank you again. See you on the other papers that we are going to be revising. Thank you.